Today we're going to talk about how to graph a radical function, and then we're going to identify some of the characteristics of this graph. These first two examples I'm going to do without a calculator, and then example 3 I'm going to pull out a graphing calculator, and we'll talk about how to identify the parts using the graph table. All of the graphs that we're going to be looking at are going to be your standard radical functions that only have reflection over the x-axis. We will not be reflecting any of these radical functions over the y-axis. So, that being said, you're only going to see two possibilities. If you have a positive square root, then we're going to see a graph that has a vertex, and then it will go up and to the right. If you have a negative square root, we're going to have our vertex, and it will go down and right. But all of our graphs are going to only go to the right. The graph will not exist to the left of the vertex. So how do we find the vertex? Each of these functions are written in vertex form. They will have an a term. In this case, it would be a 1. The a will tell me whether or not to reflect over the x-axis, and it will also tell me if there is any vertical stretch or compression. The h and the k can be used for identifying the vertex. We will change the sign of the h, but the k will remain the same. So the vertex of this first problem is -1, -5. We'll go ahead and put that on our graph. We're also going to find our y-intercept the same way that we did with quadratic functions or with absolute value functions. We will plug a 0 in for the x term. When I do that, I get 0 plus 1 underneath the square root and then -5 on the outside. The square root of 1 is 1, and 1 with a -5 is -4. We can go ahead and graph that too. The vertex and the y-intercept are enough for us to go ahead and sketch an approximate of our graph. The x-intercept. I know that this continues on, and it will eventually cross the x-intercept because it is going infinitely to the right, but it's also going infinitely up at the same time. To find out where it crosses the x-intercept, I can plug a 0 in for the y. If I do that, I get an equation that looks like this. To solve this equation, the first thing we want to do is isolate our radical. We're going to add 5 to both sides. So I've got 5 equals the square root of x plus 1. Now, since I need to get rid of the square root, I'm going to square both sides, which gives me 25 equal to x plus 1. Finally, I'll subtract 1, so x is equal to 24. Domain and range. Remember, domain only focuses on the x values of the graph, and we're going to write it in interval notation. So we'll tell how far to the left and then how far to the right this graph goes. The furthest left that this graph goes is -1. It stops there, so we're going to use a bracket. The furthest to the right that this graph goes is positive infinity. We'll use a parentheses. You might also see this written as an inequality. X is greater than or equal to -1, meaning that if I find -1, I will be using all of the x values to the right of -1. The range. The range only deals with the y values. We always talk about what is the lowest y to the highest y that this graph goes to. The lowest y is -5, and we'll use a bracket there. The highest that this graph goes is positive infinity. We could also write this as an inequality. The graph is all y values that are greater than or equal to -5. Now let's look at number 2. We're also going to do this one without a graphing calculator. The first thing we need to identify is our vertex. There isn't a number underneath the radical. So if there is no number, the number is actually a 0. So my vertex is at 0, 2. The y-intercept, if I plug a 0 in for x, I can see it's going to be the identical point as the vertex. My y-intercept is 0, 2. The graph will only cross the y-axis one time. So when we put that vertex point on the y-axis, we know it is also our y-intercept. Now, if you use a little bit of logic, this is a positive radical, which means this graph has to go up and right. If I go up and right from this vertex point, will I ever cross the x-axis? No. So I do not have any x-intercepts. Before I do the domain and range, let's find one additional point on our graph so that we can sketch an accurate graph. I can pick any x value to plug into my equation, but I want to be strategic about what I pick. It has to go underneath this radical. So I want to pick numbers that are perfect squares, which means I only have the option of 1 or 4 on this particular graph. I'm going to pick 4. If I put 4 in for the x, I get square root of 4, which is 2 plus 2. That gives me 4. So I have a point at 4, 4. And now I can sketch my graph. Domain and range. Remember, domain only deals with the x values and range deals with your y values. My domain starts at 0 and goes to positive infinity. Remember, only the x values. I will have a bracket at 0 and a parentheses at positive infinity. The range, the lowest y value to the highest y value. My lowest y value is 2, but this graph continues up infinitely. So 2 to infinity, parentheses, bracket. Don't forget, if you want to write it as an inequality instead, the domain would be all x values greater than or equal to 0, and the range would be all y values greater than or equal to 2. In number 3, I'm going to use a graphing calculator. If you're entering a function that is negative, you need to use the negative at the bottom of your calculator. To enter a square root, you will use second x squared. Make sure that you only put the x under the square root. Use your right arrow button to put the +3 on the outside. And then go ahead and graph. You'll notice on your table of values that you have this list of errors. You didn't do anything wrong. It just means that the graph does not exist on this side. So from -1 and continuing to the left, there is no graph. So the first point that you see is your vertex point, 0, 3. Now, because I have graphed this vertex point on the y-axis, I know that that is also my y-intercept. Now, to find my x-intercept, I plug a 0 in for the y. If you look at your table of values, that means that your x-intercept is at 1, 0. The domain on this graph starts at 0 and goes to positive infinity. Or all x values greater than or equal to 0. The range, the lowest possible y value for this graph, will be negative infinity because it continues downward infinitely. The highest possible y value for this graph is 3. So the bracket goes on the 3 and parentheses on the negative infinity. Now you'll notice this is not all y values greater. All of these y values are less than 3. So make sure that you write your inequality in the correct order.